Okay, we're on our last section of Chapter 5. We're working on logarithmic equations. These can be a bit daunting at first, but as you start seeing the idea, it just kind of repeats itself over and over again. So let's just jump in and start with number 1. So this is an exponential equation. So we'd like to know what is the value of x that makes 5 to the x equal to 3,125. Now, let me just show you. You could do a little trial and error. I'm not saying trial and error is bad. Like, what's 5 to the 6th power? Well, it's 15,625. That's too big. Well, maybe the answer is 5 to the 5. And sure enough, there it is. 5 to the 5 is that value. So x equals 5, and we don't have to do a lot of fancy manipulation here if we can kind of just guess at what the answer is based off of just logic or just some integer choices. All right, but it's going to get a little bit harder here where guessing is not going to be good enough. Now 3 to the 8x equals 27. Again, and now I'm going to solve this a little bit more algebraically this time. So you need to think about, well, I know 3 cubed is 27. I don't know what 3 to the 8x is, but what if we solve the equation when is 8x equal to 3? Now, see how that feels kind of algebraic? We're going to put the logarithms in here in just a minute, but I don't want to jump into that right away. So that means x is 3/8. X is 3/8. Well, the 8th will cancel with the other 8 and leave you 3 cubed, which is 27. So x is 3/8. All right. Hope you're getting the idea. Let's go on to number 3. Now, this is 3 to the 8x minus 1 equals 81. So as long as we have these like integer choices, it just turns into a simple linear equation. So if 3 cubed is 27, 3 to the 4th is 81, so 8x minus 4 must be 4. And then you just solve this linear equation, so just like the previous one. And so x equals 5/8. It would be good to check these occasionally, but these so far so good. All right, so far we've just kind of been guessing at an answer, but that's not going to be the way we're going to continue. In fact, here is a problem. I mean, when does 2 to the x equal 7? Let's get out the calculator. Let's try it. So, 2 cubed is 8. That's not it. 2 squared is 4. So it's not an integer. Is it 2 to the... I mean, it's probably closer to 3, so maybe 2.5? I mean, is that... no, that's not it. How about 2 to the 2.75? We're getting a lot closer. 2 to the 2.8? This is not the way to solve this problem, but we're getting closer. That's pretty close to 7. So how do we solve it when it's not clear or obvious? What we use is logarithms. Here we go. So what we do is we apply a logarithm. Let's use the natural logarithm. It's a common choice. So you take the natural logarithm of both sides. All right. Now log base 2 would be okay, but we don't have that on our calculator. So I wouldn't choose log base 2 in this instance. Now you use the log property to bring that x on the outside. And then, watch what you're about to see. This looks just like the change of base theorem. X is the ln of 2 divided by the ln of 7. Let's check it out. Let's see if we actually found the right answer. Ln of 2, got to close the parentheses, divided by ln of 7. And we get 0.3562. I'll write that down, just 0.3562. And so the question is, if you raise 2 to that power, will we get 7? And the answer is no. I must have messed up. I did mess up. Occasionally it's good to check yourself. So that is not right. And I'm going to leave this in here. Normally I'd edit it out, but mistakes happen, and you need to be comfortable with checking your work like that. So I didn't even realize it was wrong there. So until I checked it, the ln of 7 divided by the ln of 2. Now we're talking 2.8 something, 2.8074, 2.8704. Now you can check and raise it to that power, and you do get 7. So we have our answer. Now this is actually the answer, not the approximation over there, unless they say to use decimals. Oh, it says round to 4 decimals says needed. So we got it. So it's 2.8704. All right. It's getting a little bit long, so why don't we pause it there, and we'll do a few of these harder logarithms on the next video. Thanks.